Hey guys, it's Tech Teach again. In this lesson we're going to be learning about specific heat as we're learning thermodynamics. The formula that we're using to try to calculate heat transfer is Q equals Cm times delta T. Q is the symbol for the heat transfer, the amount of heat that's being transferred from one object to another or one fluid to another is in heat transfer. Okay, so the formula that we use is specific heat times mass times the delta T, or the change in temperature. And this will become clearer to you as we move on, but I just want you to know that specific heat is something that is a constant. Every material has a certain property that allows heat to transfer into it or out from it, and it's constant. It never changes. So the specific heat is the amount of heat per unit mass required to raise the temperature by 1 degree Celsius. So you could have a specific heat of wood, specific heat of metal, the specific heat of water, the specific heat of just about any substance. And we usually find those on data tables that are provided for us. So that's the reason it's kind of confusing, is because this is kind of a known and it's a constant. So if you have one problem that uses the specific heat of aluminum, all the problems you have that use that specific heat are going to be the same. The specific heat of water is 1 calorie per gram Celsius degree, which is equal to 4.186 joules per gram Celsius degree. Our problems are in kilograms per Celsius degree, so ours is 4,186, or 4,184 is what I've calculated. So it's a tiny bit different, but not much. Okay, so let's move on to the problem. The problem here is given to you that you're calculating the energy transferred when a block of aluminum at 90 degrees Celsius is placed in 4 liters or 4 kilograms of water at 25 degrees Celsius if the final temperature becomes 40 degrees Celsius. Okay, so the first step in anything is write down everything that you know. So we know the mass of water is 4 kilograms. It's right there. We know that the starting temperature, T of S, of the water is 25 degrees Celsius. It's right there. We know that the final temperature for both the water and the aluminum is going to be 40 degrees Celsius. It's right there. It says the final temperature becomes 40 degrees Celsius. And we also know that the beginning temperature of the aluminum is 90 degrees Celsius. It says it right there. The specific heat is something that we're given. So we're saying 4,184 joules per kilogram times Celsius degree for the water, and we're saying 900 joules per kilogram Celsius degree for the aluminum. These are the knowns that we've gotten off of tables and found on the internet, and we know these are the accurate values. The unknowns, what are we looking for? The first thing it says calculate the energy transferred. So you got to read your clue here and then calculate Q. The second thing that we don't know, we know that we know the mass of water, but we don't know how big this block of metal is. So we're going to try to calculate that as well while we're at it. First of all, the formula that we're going to use is the heat transfer of water is equal to the mass of the water times the specific heat of the water times the change in temperature of the water. So as we go down, what we're doing is we're saying H2O, and we're plugging in the numbers from up here into here, is equal to 4 kilograms times 4,184 joules per kilogram Celsius degree times the change in temperature. Starts at 90 degrees and moves down to 40 degrees. That's not correct. Had to make a quick change there. It starts at 25 degrees and ends up at 40 degrees. So there's a temperature difference there of about 15 degrees. This is the formula we use. We'll get to it in the next video.